So first of all, this is a right angle. We know that a right angle has three lengths. That one is called hypotenuse. Then another one is called base, and the rest of one is called perpendicular line, opposite line. So how can we identify these three lines? First of all, the opposite of 90-degree angle, that means the right angle, will be the hypotenuse. Then if I consider this as an angle, angle C, then the opposite of angle C will be the perpendicular line. Or you can also call it opposite line. And the rest one is called base. So here AB is opposite line or the perpendicular line, and BC is base. In respect of angle C, in respect of angle C. Now, if I consider angle A, then the opposite of angle A will be this length BC. Then this BC will be perpendicular line. So the rest one will be base. So actually identification of base and perpendicular line depend on the respective angles. Now let's do number 23 from page number 123. So first of all, we have to mark all the points from this figure. For example, I mark it with A, B, C, D. So I mark these 4 points from the picture of 23. Now I will separate this figure into two parts. So this is the first one and this is the second one. Now from these two figures, I have to consider that where at least two of these values are given. So in the picture number 1, you can see that there are two values given here. And in picture number 2, there is only one value that is given. So I have to consider picture number 1 to solve. And I also have to find that the common length of this two triangle. So here BC is the common length of this two triangle. So for this reason, I have to find the value of BC from triangle 1. From the picture number 1, the value of this angle is given. So I have to consider the value of angle A. That means angle A is the respective A of this triangle. So BC is just opposite of angle A. BC is just opposite of angle A. So BC will be the perpendicular line for this triangle. And this one will be hypo. So this one will be base. So as I have to find the value of BC, that means the value of perpendicular line. So I have to find a formula that consists of hypotenuse and perpendicular line. So now we all know that sine theta equal to perpendicular line divided by hypotenuse. That means sine A equal to perpendicular line divided by hypotenuse. So if I just calculate this line, so sine A, that means sine 27.2 equal to perpendicular line. So the value of perpendicular line, I have to find this perpendicular line, and the value of hypotenuse will be 100. So 100. So to find the perpendicular line, just I have to multiply sine 27.2 multiply 100. So if I use calculator, it will be 45.7. So now I can input this value here, 45.7. Now this is the second triangle. That means this part of this math, and this x is the respective triangle. So previously I just pointed this as B, C, and D. So here x is the respective angle. So the opposite of the respective angle will be perpendicular line, and the opposite of right angle will be hypotenuse, and the rest will be the base. So I have to find the value of x. So now I have to find a formula which consists of hypotenuse and perpendicular line. So we know that sine theta, that means sine x, equal to perpendicular line divided by hypotenuse. So we can write sine x equal to, here the value of perpendicular line is 45.7 and hypotenuse is 85. So we can write, sorry, so we can write x equal to sine inverse. If I change the side of this sine, so it will be sine inverse 45.785. So in the calculator, to get sine inverse, you have to press shift and sine. So as I don't have any calculator, scientific calculator, I don't know the answer. Please find the answer. So this is the way how we can solve this problem of number 23 from page number 123.